Welcome back to Anning Analytics, my channel where I teach beginner programmers that no CS topic is too difficult to learn if given enough dedication. We are now approaching the final videos in the series Making Gerald. In the first 3 videos released in the series, I talked about how to create the brain of Gerald. In the 4th video, I talked about the concept of threading and how it ultimately is going to fit into our entire project of creating Gerald. To finish out the series, what we're going to do now is create what you see in front of you right now, the Gerald visualizer. Whenever I think of something like a robot talking, I've always pictured a sine wave changing amplitude depending on the level of audio input that is into the computer. So as you can see, if we talk super quietly or we talk really loudly, it'll change the amplitude depending on the level of audio input. With that being said, we're now creating the face of our Gerald GPT best friend. Let's get started. We're going to make a new file and we're going to save it as sine.py. After we've named it, just hit enter. In order to start this project, we need to download 3 libraries. We need to download the Pygame library, the math library, and the PyAudio library. Once you have these 3 written out, we need to make sure that we go to the command prompt to make sure that we've downloaded the proper libraries. The first library we're going to install is Pygame. On your computer, it should download. On mine, I've already done this. The next library that we're going to install is PyAudio. Again, my computer, I've already downloaded this. On yours, it should say that the file is downloaded. The math library isn't something that you need to download because it already comes standard when you download Python initially on your computer. Today's video is going to be a little bit longer just because there's going to be multiple parts that we need to test, so bear with me. If you already know how to set up Pygame and you don't need a reminder about this, skip to later in the video. We have to initialize the Pygame window with a few variables. I like to make both my screen width and screen height variables the same number just to begin with Pygame. Next, we're going to call pygame.init, and this initializes all imported Pygame modules. Then we're going to set the display by typing pygame.display.setCaption. Then we set the variable screen, which sets up the actual width and height of the screen. Then we need to create the variable clock, which just keeps track of time and helps us with frames per second later on. Next, we're going to create a boolean called running. And then we're going to create a while loop, which will handle the continuous cycle of our Pygame window. And then what we're going to do within this game loop is create another for loop which will handle all of the events such as keystrokes or any other type of input. And then we need to make sure that within this for loop that's within the while loop, we create an if statement that catches any keystroke saying, okay, it's now time to quit the Pygame window. And if the X button at the top right of the Pygame window is clicked, we want to make sure that running is turned to false, and then it'll stop the entire loop, which closes out the Pygame window. At the end of the while loop, we want to include the statement clock.tick60, which means we want to limit the amount of times this loop is executed every second to only 60 times. We can think about this in terms of frames per second. And after our while loop, we want to call the statement pygame.quit, which shuts down the entire Pygame window. Hit Ctrl S, and let's test this in the command prompt to see if it appears. Once you're in the correct directory, type out the name of your file, hit enter. Alright, we've got a nice 500 by 500 Pygame window. We've got the name up top that says Gerald Visualizer, and if we hit X, it exits the loop and quits the Pygame window. Now that we have the Pygame window open, let's work on getting our microphone input and a sine wave to appear on the screen. I won't be going into full depth about PyAudio because frankly there's just so much to unpack and I don't quite understand it all. However, if you want to check it out, I'm going to provide a link in the description and you can go investigate PyAudio for yourself. We're going to create 4 more variables up at the top to handle our audio initialization. Then we need to create another variable called P, which is assigned to the PyAudio object. And then we need to create a variable called stream to create an open audio stream. And we're going to create the stream by calling that PyAudio object and then providing the statement .open after it, which is a method where we're providing all of these extra arguments, format, channels, rate, input, and frames per buffer here. Now that that's done, we've got 2 methods to create and then a little bit more code to fill in with the game loop to handle the 2 different methods that we're going to be using. The first method that we're going to create is called getMicrophoneInputLevel. The second method we're going to create is called drawSineWave. And in order to draw this sine wave, ultimately what we're going to be getting from our getMicrophoneInputLevel method is an amplitude number. And then once we have that amplitude number, we're going to pass it into the draw sine wave method. Next, we create a data variable where it reads the audio. Then we're going to create a variable called RMS, which stands for root mean squared. Alright, and then I won't lie, the highlighted part that I have here that just magically appeared, I did get a little bit of help from ChatGPT. ChatGPT, in my mind, is like a calculator when it comes to math. Of course, it's always nice to remind yourself that you can do math the long way. However, when you have a calculator next to you and you have a time crunch, you should probably use it. I didn't really quite understand how to calculate the root mean squared in terms of dealing with audio input levels, so I had a little bit of help. Let's think of the microphone input like a roller coaster. The root mean square and this formula sort of acts as finding the average height of that roller coaster for a period of time. And that period of time in our case is the chunk that we described up above. To make sure that our microphone input level method works, what we're going to do now is print out the RMS inside of our command prompt. Hit Control S and let's head over to the command prompt. Hit enter. Oh, what do we see here? Ah yes, just comment out this. Hit Control S one more time and head back over to your command prompt. Hello. Alright, so it's printing out a ridiculous amount of numbers. We see it, great. Alright, we can hit X. So these are all of our root mean squared variables printed out in the command prompt that shows the level of audio input. Minimize that. Once you're back in your file, get rid of the comment. And now we can begin our second method. What I like to do before I draw any type of thing to the Pygame window is ensure that the screen is the color that we want, which is black. And then since we're dealing with a sine wave, which is a collection of points that are consistently changing, we need to create a new variable called points, which holds an array that will ultimately store all of the plotted points within our sine wave. Now, if you recall in the beginning of the video when I showed you the example of what our sine wave would do, we want to make sure if there's not enough sound being input into the mic, we just want a flat line. So ultimately what we want is to create a minimum sound level to check if enough audio is being detected. So we're going to create an if statement that says if amplitude is greater than 10, then continue. And we'll worry about the else statement later. And then within the first part of our if statement, here's the for loop that will handle creating all of the points within our sine wave. And then this part is much easier because ultimately, if we don't have any audio, we just want it drawing a flat line. Once all of the points have been appended to this array, we need to draw them to the screen. To draw all of the lines to the screen, call pygame.drawLines, and then we pass it a variety of arguments. Here's our screen object that we created before. Here's the color of what we want all the points to be. This Boolean value determines if the line is closed or not. If it's true, the function will draw a line from the first point of the shape to the last to close it. But if it's false, it just remains open. So since we're drawing a sine wave and we don't want the first and last point to be connected, we need to set this equal to false. Right here, we're passing in an array of tuples that are the x and y points of each point in our sine wave. And then this 2 right here is how many pixels wide we want each point to be. And after this, we type pygame.display.flip, which basically paints this new line to the screen. After finishing the draw sine wave method, we need to create another variable down here called amplitude, and we're going to set the initial amplitude equal to 100. And then within our game loop, we create a new variable called amplitude adjustment. As you can see within our command prompt, these variables are incredibly large. So what we're going to do is divide all of them by 50 to have a dampened amplitude level for our sine wave. After creating our amplitude adjustment variable, we create this new variable called amplitude, and then we're setting it equal to this max function, which basically says if this one's 0, then we want to take 10. But if this one is greater than 10, then we'll take the amplitude adjustment. And we do this because when we're dividing by 50, this has the chance to create incredibly small numbers that won't even show on our sine wave visualizer. So we want to create a way for there to be a minimum amplitude level. And then finally, we can delete this print statement because we're going to be calling the function draw sine wave, and we're going to pass the variable amplitude through to it. Now make sure to hit Control S, and let's go test this over in the command prompt. Hit up on the arrow keys, hit enter, and just like that, let's go! Alright, man, that feels good to have done. Alright, and just like that, you now have your own Gerald visualizer. So now looking forward, the last video in this series is going to be combining this Gerald visualizer with our Gerald GPT brain. And this is where that fourth video where I talked about threading is really going to come into play. And I hope now you're starting to see where this idea of threading comes into play, because we've got this GPT brain doing all of this work in the background, while at the same time we want the Gerald visualizer to be picking up the microphone input level so that it creates this sine wave showing how loud or how softly we're talking. Thank you for watching my video. I hope you enjoyed. If you did, please consider hitting the like button and subscribing. It really helps me reach more people, and it motivates me to bring you more amazing content. Thanks again, stay hungry for knowledge, and see you in the next video.